You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back. Sometimes you see these industry shifts, and it's not just like tweaking things anymore. It feels like they're really tearing down old ideas and building something totally new.
Oh, absolutely. The velocity is just incredible right now.
Yeah, and today we've grabbed a few developments that I think really reset the baseline for data performance. We're talking core databases, huge cloud platforms, the works.
And it's not just about new tools, is it? It's fundamental architectural shifts we're seeing, moving away from just scaling up towards distributed, resilient, cloud-native thinking.
Exactly. Less, how do we store more?
Yeah.
And more, how do we make this thing fault-tolerant, global, and cheaper all at once? So today, let's try and pull out the key nuggets here, the big performance wins, the strategic tool choices, and maybe touch on how AI is starting to force our hand on infrastructure.
Sound good?
Sounds great. Let's dive in.
Okay, let's start right at the bottom, the infrastructure backbone. Because operating globally, that needs completely new ways of thinking architecturally.
And Cloudflare, they're already huge in networking, right?
Right.
But they just dropped this fully managed data platform. That feels like a big move.
It's a massive gauntlet thrown down, absolutely. Yeah. The core piece, I think, is this R2 SQL.
Right.
So basically, it's a distributed SQL engine built on Apache DataFusion, which is already known for being super fast.
Okay.
And the kicker is it lets you run analytics, like Petabyte-Scale stuff, directly on their R2 object storage.
Directly on object storage, without moving it first.
Exactly. They use their global network for the distributed query part, and crucially, it's compatible with Apache Iceberg.
Ah, Iceberg. So that handles the metadata, finding the right files, all that complexity at scale.
Precisely. It makes querying object storage actually feasible for analytics.
But here's the bit that caught my eye. The money angle. They're pushing open standards and supposedly eliminating data egress fees.
That's the headline grabber.
Serverless, usage-based pricing, no penalty for getting your data out. That sounds, well, too good to be true compared to the big cloud guys. What's the catch?
Well, that's the multi-billion-dollar question, isn't it? It's probably a mix of things. Architecturally, they're tightly coupling compute and storage on their edge network.
Okay.
And optimizing heavily with DataFusion probably cuts down their internal cost compared to how traditional clouds were maybe built, years ago.
Yeah.
So they can pass some of that saving on.
So it shifts the lock-in from storage egress fees to maybe needing their specific compute and network edge.
Potentially, yeah. Or maybe it just forces the others to compete harder on egress. It's definitely a strategic play.
Interesting. Okay. Shifting from cloud strategy down to the internal plumbing, let's talk Netflix. Operating at their scale, stability is everything.
Everything.
And they built this solution for something maybe not everyone thinks about as a separate component. The write-ahead log, the wall.
Right. For folks maybe not deep in database internals, the wall is fundamental. It's how databases ensure durability, atomicity, right?
Yeah.
Right to the log before you commit the actual change.
Standard stuff.
Okay.
So what was wrong with existing walls for Netflix?
Well, at their scale, across thousands of microservices, they were hitting critical issues. Data loss, corruption, huge pains trying to coordinate updates across multiple partitions or services. It was complex and brittle.
So they needed something generic, something central.
Exactly. A generic centralized wall system. They built it using Kafka for the core log streaming. Durable storage, obviously. But they cleverly used SQS for delayed queues.
Delayed queues, like for retry.
Yeah, like a sophisticated dead letter queue mechanism. If something fails processing a log entry, it can be delayed and retried gracefully without blocking everything else. It handles transient failures much better.
So the big win is abstracting away that core problem of distributed data consistency and fault tolerance. One central, reliable wall everyone can use.
Pretty much. Instead of every team reinventing the wheel, often poorly, they standardize mission-critical resilience. It simplifies life immensely for their service developers.
Makes sense. We see a similar kind of evolutionary pressure over at Airbnb with their key value store, Mussel. Version 1 apparently was hitting walls.
Yeah, Mussel v1 had issues. Operational complexity was a big one, but also consistency limitations.
And when you're doing dynamic pricing or trying to catch fraud in real time, eventual consistency sometimes just doesn't cut it, right?
Exactly. It directly impacts the business. So Mussel v2 sounds like a ground-up rewrite.
What changed?
They moved to a NewSQL backend, something more performant and scalable. They built a Kubernetes-native control plane, which helps with operations. And they implemented dynamic range sharding for better load balancing.
Okay, tech upgrades, but functionally.
The big functional leap is offering explicit choices between immediate and eventual consistency.
Ah, so the developer can choose based on the use case.
Precisely. You don't need absolute immediate consistency for, say, updating hotel descriptions in a low-traffic area. Eventual is fine, saves resources.
But for that fraud check during booking, you need it locked down, immediate.
Absolutely. It forces developers to be intentional. What consistency level does this specific feature really need? It's a trade-off between latency, cost, and correctness.
Which is a much more mature way to design systems, really, making conscious choices.
Definitely. But it does push more responsibility onto the development teams to understand those trade-offs properly.
True. Okay, so we have these evolving architectures like Mussel v2, but they're useless if the underlying engines can't keep up.
Right.
So let's talk about those core engine power-ups. Starting with the database, pretty much everyone uses or touches.
Oh.
PostgreSQL PG18 is coming with some big stuff.
Huge stuff. The headline technical feature, I think, is the new asynchronous I/O subsystem.
Async I/O. What does that actually mean for performance?
It means Postgres can handle reading and writing data from storage much more efficiently without blocking processing threads as much. They're seeing up to 3 times improvement in storage read performance in some benchmarks.
3 times.
Mm-hmm.
Wow. For I/O-bound workloads, that's massive. Less waiting on disk.
Exactly. Faster queries, better index usage, potentially lower hardware requirements. It's a game changer operationally.
And for developers?
Yeah.
Any nice quality of life improvements?
Oh, yeah. Native support for UUI DV7 is one I know people are excited about.
Why UUI DV7 specifically?
It combines the uniqueness of UUIDs with a time-ordered component. This makes them much friendlier for primary keys and databases because they index way better than purely random UUIDs like UUID v4. Less index fragmentation.
Okay. Streamlines things.
What else? Virtual generated columns. This is pretty neat.
Virtual.
Yeah, so instead of calculating a derived value when you write the row and storing it, wasting space, it calculates the value only when you read the row.
So you trade storage cost and write latency for a little bit of compute cost on read.
Exactly, which is often a very good trade-off, especially for columns you don't read all the time or in high-volume write scenarios.
Smart. And I saw something about the returning clause.
Yes, finally. You can now access both the old and new OB row values within the returning clause of an update or delete.
So you don't need complex triggers just to capture what changed anymore.
Exactly. It makes auditing and change data capture so much cleaner. No more writing those fiddly, sometimes buggy trigger functions just for that. Huge simplification.
That's the kind of steady, thoughtful evolution we love about Postgres.
It really is. But, if we want to talk about just raw, almost unbelievable speed, we have to mention the Haydex performance thing.
Oh, yeah. That number scaling from 0 to, what was it, 178.6 billion rows per second in 30 days.
Billion with a B. It sounds completely absurd.
It really does. What was the secret sauce there? What's the lesson?
The core lesson seems to be that modern I/O architecture, especially with NVM drives and fast networks, is capable of incredible throughput, but our software hasn't always kept up.
So the bottleneck moved.
Right. Their breakthrough wasn't one magic trick. It was realizing they needed to fundamentally shift to doing large sequential reads whenever possible, and then intense, relentless optimization guided by profilers.
Okay, large reads, profiling. Anything else?
The synergistic effect. They found that optimizing one part of the I/O path often dramatically improved the effectiveness of optimizations elsewhere. Little fixes compounded into massive gains.
So it wasn't additive, it was multiplicative.
Kind of, yeah. Tuning the whole pipeline together yielded way more than just the sum of the parts. It's a lesson in holistic system optimization.
And we see that performance focus everywhere, right?
Yeah.
Even in query engines like Apache DataFusion, which Cloudflare is using.
Absolutely. DataFusion 50.0.0 just dropped with significant bumps. Things like dynamic filter pushdown.
Meaning it pushes filters closer to the data source.
Yeah. Avoiding reading unnecessary data in the first place, they're seeing order of magnitude improvements in scan efficiency from that.
Order of magnitude, wow.
And they rewrote their nested loop join algorithm. It's apparently up to 5x faster now, using 99% less memory in some cases.
99% less memory. That directly translates to cost savings in the cloud.
Directly. These aren't just academic benchmarks. They have real-world impact on your cloud bill and query times.
Okay, so we've got faster engines, smarter infrastructure. Let's pivot a bit to strategy. Choosing the right tools, writing good queries.
Crucial stuff.
There's always this debate you hear, especially in the Python data world, DuckDB versus polars. Are they competitors?
It's a classic case of people comparing apples and oranges, I think. It's really not an or situation.
So different tools for different jobs.
Totally. DuckDB is amazing because it's basically a full-featured, in-process analytical database. Simple install, speaks SQL, can query data frames, Parquet files, S3, whatever. Super versatile.
Database features are key there.
Right. Polars, on the other hand, is laser-focused on being the fastest possible data frame library. It does not try to be a database. It's for high-speed data manipulation in memory, often using that functional programming method chaining style.
So if you need database-like operations, transactions, persistent storage management, DuckDB, if you just need to crunch data frames super fast, Polars.
That's pretty much the gist, yeah. Use the right tool for the job. They actually complement each other quite well in many pipelines.
Okay, sticking with queries. SQL. You mentioned a really important point about a tiny two-letter word that can cause massive pain. Or.
Ah, yes, the dreaded or clause in where conditions. It seems so innocuous, right?
Yeah, where status A or priority equals high. Looks simple. Why is it often so expensive?
The problem is query planners often struggle with or conditions that span multiple columns, especially if those columns aren't part of the same composite index.
It can't use the indexes efficiently.
Often, no. It might have to do 2 separate index scans and then merge the results, or worse, it might just give up and fall back to a full table scan.
Reading the entire table just because of an or. Ouch.
Exactly. Suddenly, your carefully indexed query is grinding to a halt. The practical advice is, if you have a slow query with a complex or, try rewriting it.
How?
Sometimes you can use union or union all to combine the results of 2 simpler queries, each hitting an index efficiently.
Okay.
Or sometimes it's a sign your schema needs rethinking. Maybe split off some attributes into an extension table so you can query them more cleanly without the or.
And the potential payoff.
People have reported speedups of up to 100x just by eliminating a bad or clause.
100 times faster. Just by rewriting an OR. Okay, that's something everyone needs to check in their code base.
Yeah.
Now.
Yeah, seriously. It's one of those little things that can have an outsized impact.
All right, still on the topic of data itself, the file formats we use, Parquet has been king for analytics for ages. Is that changing?
Parquet is still definitely the dominant format for large-scale analytical workloads. Its columnar nature, compression, encoding schemes, and massive ecosystem support are hard to beat for general batch analytics.
Wow.
But we're seeing new formats emerge specifically tailored for newer workloads, especially around AI and machine learning.
Like what?
Formats like BTR blocks, Lance, Vortex, Fastlanes, Nimble. They're optimized for different things. Some focus on super fast access on modern hardware like NVMe drives using techniques like SIMD.
Okay, faster hardware access.
Others are designed for better integration with GPUs, or for handling unstructured or semi-structured data common in AI pipelines, or for very low latency point lookups.
So Parquet for big scans, these newer formats for more specialized, high-speed, maybe AI-related access patterns.
That's a reasonable way to think about it right now. The landscape is evolving because the demands are evolving, driven heavily by ML/AI needs.
Before we dive fully into that AI future, though, let's touch on a massive engineering feat that speaks to managing complexity today. Uber's Spark migration.
Oh, yeah, that was impressive. Migrating, 40,000 Spark applications, over 2 million jobs, from Spark 2.4 to 3.3?
In 6 months. The scale is just mind-boggling. How do you even approach something like that without breaking everything?
The sheer risk of subtle regressions or breakages across that many applications is immense. You can't manually test everything.
So automation had to be the key.
Absolutely. They leaned heavily on an open source tool called Polyglot Piranha.
Polyglot Piranha. Catchy name. What does it do?
It parses source code multiple languages, hence polyglot, into an abstract syntax tree, an AST.
Okay, like a structured representation of the code.
Exactly. Once you have the AST, you can define rules to automatically transform the code. Find patterns specific to Spark 2.4 APIs, replace them with the Spark 3.3 equivalents, handle configuration changes, etc. All programmatically.
So they essentially wrote code to rewrite their code at scale.
Pretty much. The lesson isn't just use ASTs, it's about building the confidence and the tooling to apply these large-scale automated refactoring safely. It's the only way to manage that kind of complexity and velocity.
That ability to manage complexity and change at scale feels like the perfect lead-in to the bigger picture. Industry consolidation and the future shaped by AI. We're seeing signs of market maturity, right? Like the reported talks between Fivetran and DB Labs for a merger. That would be huge.
A multi-billion-dollar deal, potentially. It makes a lot of strategic sense if you think about it.
How so?
Fivetran is dominant in data movement, getting data into the warehouse reliably. DBT Labs is the leader in data transformation and modeling within the warehouse.
So combining them creates a more unified stack. Ingestion to analytics.
Exactly. Reduces fragmentation for customers. And crucially, it positions them very strongly for the wave of AI-driven data preparation. AI needs clean, reliable, well-modeled data, and that combination covers the pipeline.
The great consolidation, some are calling it.
Seems like it's underway, yeah. Building the platforms for the next era.
And that next era seems inextricably linked with AI. Which brings us to this idea of agent-first data systems. What on earth does that mean? Our current systems aren't agent-first.
Well, think about how we've built data warehouses for the last couple of decades. They're optimized for humans running relatively predictable SQL queries against rigid, predefined schemas. We value perfect structure, exact answers.
Right. Reports, dashboards.
AI agents, on the other hand, operate differently. They need to explore, hypothesize, run thousands of speculative queries, deal with ambiguity, maybe get approximate answers quickly. It's a fundamentally different query pattern.
Thousands of overlapping speculative queries. Our current query optimizers would probably just, like, melt down, wouldn't they?
They're not designed for it. So the argument is we need architectural shifts. Things like probe optimizers that can handle this barrage of exploratory agent requests efficiently.
Okay. Smarter optimizers. What else?
Native support for cheap branching and rollback. Imagine an agent exploring a hypothesis. You want it to be able to create a temporary branch of the data state, explore it, and then discard it cheaply if it's a dead end. Not commit huge resources.
Like Git for data, but lightweight and integrated.
Kind of, yeah. And maybe most fundamentally shifting our modeling away from just rigid tables and columns towards more universal semantic primitives.
Semantic primitives, like
Thinking in terms of core concepts. Events, things, places, ideas, and modeling the relationships between them explicitly. This event leads to that outcome. This concept contains that idea. This person is near that location, making the meaning machine readable.
so the system understands the semantics, not just the structure.
That's the idea. Because agents need to reason about relationships and meaning to be truly useful. Flexibility, approximation, semantic reasoning. These need to become core capabilities, not awkward add-ons.
Wow. So if we move that way, does the whole idea of a single, rigid, central data warehouse, does that become obsolete?
Maybe obsolete is too strong, but it definitely evolves. The need for a central source of truth probably remains, but its structure and capabilities have to become far more flexible, more graph-like, more semantically aware. We're moving from optimizing structured storage to optimizing what some call semantic space-time.
Semantic space-time. Okay. My head hurts a little, but in the good way. That's a profound shift in thinking.
It really is. It challenges a lot of assumptions.
So this has been quite a tour, from low-level I/O to the future of AI agents.
Yeah, quite the journey. To quickly wrap up, we've seen a new performance baseline being set, right? Postgres 18 async I/O, the crazy Haydex numbers showing I/O potential. We saw the absolute need for architectural resilience, thinking about things like Netflix's generic wall, Airbnb's consistency choices in Mussel v2.
Right. Building for scale and failure.
And we're seeing strategic consolidation like Fivetran Bet, likely gearing up for this AI-driven future that demands fundamental changes to how we store, query, and even model data.
Excellent summary. It really feels like we've spent, 20 years perfecting systems to serve these rigid, human-defined schemas and reports really well.
Yeah, we got good at that.
But if the future is all about these speculative, approximate, agent-based queries, navigating semantic spacetime, here's the thought I want to leave people with. How much of our current data architecture do we actually need to completely abandon to truly embrace that flexibility?
Oof. That is the multi-billion-dollar question, isn't it? What stays? What goes? What gets fundamentally rebuilt?
Something to chew on for your next project planning meeting. Definitely. Go explore those implications.
Spoken Tech for your ears.